everyone. In this video, I'm going to be doing a quick video and a quick explanation of polarity. So, polarity is quite simple. It's really just kind of thinking about things, I guess, like hypothetically. Not hypothetically, but, what's the word I'm looking for? Critically thinking about these sort of things, right? So, as long as you understand what the word polarity means and how different atoms, how they're a little bit more electronegative than others, then you're good. So basically what polarity is, it's very similar to electronegativity and how we were talking about bond polarity, and how I have a video on bond polarity if you want to view that as well. So it's very similar to that, but instead of focusing in on each individual bond and its polarity, we're focusing on a whole molecule and its polarity. So basically, if something is polar, that means that there is an unequal sharing of electrons within a molecule. So let's look at some examples of some unequal sharing and some equal sharing, right? So if we have something like dihydrogen monoxide, aka water, you can see that by the way, the purple like little shaded kind of spot represents the electron cloud, and yeah. So you can see here that because oxygen is more electronegative than hydrogen, it's going to pull in those electrons. With that being said, that means that it's going to be polar because there's an unequal sharing. Again, I love using the tug of war example. That's probably like one of my favorites. If you think about the hydrogen and the oxygen having a tug of war, the oxygen is a lot stronger than those hydrogens, so it's going to be pulling those electrons towards it, right? Which means that it's going to be an unequal sharing of electrons. So let's look at something that is nonpolar. So we can see that we have a carbon in the center with 4 hydrogens around it. So with a carbon in the center and 4 equally things around, it doesn't have to be hydrogen, it can be fluorine, chlorine, what else is out there that we could attach to it? Fluorine, chlorine, what other halogens are there? It doesn't matter, but either way, if they are all the same, then it's all going to be equally pooled the same, right? So they're going to be sharing all of those electrons because they're none of these are stronger than the other. You could say that carbon is stronger, but because it's in the center, it's not doing any pushing or pulling, so it itself is not making anything unequal. So let's look at another polar one, very similar, but this time we're going to add on a chlorine to it. Chlorine is a lot more electronegative than hydrogen, and you don't have to know that. You just have to know that chlorine is different from hydrogen. So chlorine's just different. You can think of it as that as well. And because it's different, it's stronger. Hydrogen is not very electronegative when compared to other electronegative things. But that doesn't matter, right? Even if the hydrogen was stronger than the chlorine, we know that one of them is going to be pulling at it a lot more, which means that it's going to be polar. In this example, chlorine is more electronegative. Again, you don't necessarily have to know that, but you can see in this drawing here, we can see how it's more polar. It's because that electron cloud is getting pulled towards those chlorines, so it's an unequal sharing of those electrons. Alright, so now let's look at an example of something else that's nonpolar. I forget the wording that he says for that. Dinuclear, homodinuclear, or something like that. Either way, 2 of the same things bonded together. That is going to be nonpolar because, again, if you think of it like the tug of war thing, if you have a strong person pulling on the tug of war, so we have somebody that's really strong, and you have somebody else that's the same strength, and they're pulling at the same time, the flag's not going to move. Neither of them are going to win, so they're just kind of pulling at each other, nothing's happening. Same thing here. These have the exact same electronegativity because they are the exact same atom, so that means that nothing's moving. No electrons are going one certain way, and one is not being unequally shared, so that means that they have the same amount of electrons being pulled in the same direction, so it's going to be nonpolar. So that's just kind of like a simple rundown. And let's do some practice problems with that. So I'll go through the first one, and I highly encourage you all to try the last ones on your own. So first, let's draw this out. So we have C and C in the center, and we're going to add on our H's, and then we'll check to see if we have all of the electrons that we need. So carbon is 4. 4 times 2 is 8 plus 6. I need a calculator for that, embarrassingly enough. 8 plus 6 means that we're going to need 14. So we have 1, 2, 3, 4, 5, 6, 7 times 2. It's going to be 14. So we don't have any more electrons to add, right? So let's look at here. So I can already tell that this is going to be nonpolar, mainly because of the fact that there's nothing that's pulling anything different. We can say this is also symmetrical, which might help. So if this is unsymmetrical, so let's say that this was something like oxygen and it would be doubly bonded and there would be other things on the side, that would mean that it's going to be polar because oxygen is more electronegative, so there's something different in there. But we can say this is symmetrical and these are the exact same things and they're being pulled by the exact same thing. So either way, nothing really special going on here, and there's no pooling or unsharing of electrons. They're all sharing it very evenly because it's basically the same thing. So we're going to say that that is nonpolar for number 1. Alright, so let's look at HBr. Again, highly encourage you guys to pause and try these out on your own, but let's take a look at HBr. So HBr. So right away, because this is something that is just two things bonded together and they're not the same, I'm going to say this is polar. Again, reason being they're not the same thing, and again, in a tug of war, if you have one thing that's stronger than the other thing, it's going to pull it, so the electrons are getting pulled towards the boron, so we're going to say that's polar. And now let's take a look at O2. So that's O2, and again, they're actually the same thing being pulled. You might think, okay, well, this thing has a double bond, that might affect it. It doesn't. Double bonds don't mean much if they're the same two atoms. Like these are the same thing, like literally the exact same thing being pulled. So it's a strong guy and a strong guy, they're both pulling, and they're gonna get nowhere. Or a strong girl. Don't mean to. Okay, it's getting too political. Not political, but I was gonna get too deep into women are strong too, but very true, women are strong too. So it could be a strong man, a strong woman, whatever. Okay, so let's look at the next one. We're gonna have carbon in the center, and we're gonna have hydrogen and chlorine and another chlorine. Once we do our valence electron, it's gonna look something like this. Same thing with bromine. Bromine's gonna have those shells too, or those outer shell electrons. So let's take a look. So we have carbon in the center, and we have 3 things around it that are the same and 1 thing that's different. Because there's going to be something different, these are going to be pulling at the electrons more. So I'm going to say this is polar, purely because of the fact that it's not being evenly shared, right? So we have something that's strong, something that's strong, something that's strong, something that's weak. It's not gonna be a fun situation for the carbon. It's all gonna get pulled to one side, meaning that it's gonna be polar. Alright, so that was that for polarity. I hope you guys enjoyed the video, and thank you all for watching.